All right, let's dive into one of the most important, yet kind of invisible, forces that powers our entire digital world.
I mean, just think about your day for a second. Every single time you send a quick text or, a message on an app,
Or maybe when you're logging into your bank account to check your balance.
Well, there's something working silently in the background every single time. It's like a digital bodyguard, and its whole job is to protect your most sensitive information.
And that secret protector? That's encryption. It's really the unsung hero of internet security. So let's pull back the curtain and see exactly how it all works.
Okay, so what does this digital bodyguard actually do? Well, at its core, its entire job is to turn your normal, everyday messages into what are basically unbreakable secrets.
So here's the official breakdown. Encryption takes data that anyone can read, we call that plain text, and just scrambles it all up. The whole point is to make sure that if your data gets intercepted, it's just meaningless gibberish to anyone who doesn't have the special key. I mean, without this step, your information is basically an open book for anyone to read.
And really, it's that simple. Just think of it like one of those secret languages you had with a friend when you were a kid, right? Only the two of you had the key to figure out what you were saying. That's pretty much encryption in a nutshell.
And why do we need it so badly? Well, because our data is always on the move. It's going from your phone, through a Wi-Fi router, zipping across the internet, between different devices, all the way into the cloud. And get this, every single one of those steps is a potential weak spot, a place where someone could try to peek.
Okay, let's make this a little more real. Let's just say your password is hello123. Super simple, totally readable, and yeah, incredibly vulnerable if it's just sitting out in the open like that.
But now, watch what happens when we throw encryption at it. A really powerful mathematical algorithm gets to work on that simple password.
And bam, it becomes this, a completely meaningless jumble of characters. And this scrambled, unreadable version, it has a name. It's called ciphertext. This is what a hacker would see if they tried to snoop on your data. Just pure gibberish.
So the big question is, how is this secret code actually made? Well, it turns out there are two main ways we go about creating this ciphertext. All right, let's break these down. First up, we've got symmetric encryption. The easiest way to think about this is like your house key. You use one single key to lock the door, and you use that exact same key to unlock it. It's super fast and efficient. Then you've got asymmetric encryption. This is a bit different. Think of this one like a personal lockbox with a mail slot. Anyone can drop a letter in through that public slot, that's the public key, but only you have the special private key to actually open the box and read what's inside. So the big difference here, the most crucial point, is just the number of keys you're using.
Now, I know this might sound a little abstract, but believe me, you are using both of these types of encryption all day, every single day, and you probably don't even realize it.
You know that little padlock you see next to a website's address in your browser? Yep, that's HTTPS, and it's powered by encryption. It's what makes it safe to shop online. And your banking app? Totally encrypted. Your private messages on apps like WhatsApp or Signal? Encrypted. The files you save to cloud storage? Even your password managers. All these things we kind of take for granted are only possible because encryption is in the background, keeping them safe and secure.
So, let's zoom in on a really powerful example that you've probably heard about, especially with messaging apps. We're talking about end-to-end encryption.
This right here is what true privacy looks like in action. The moment you hit send on a message, it gets scrambled into that secret code right on your device. Then it travels through the company's servers, like WhatsApp servers, as total gibberish. They can't read it. It only gets unscrambled back into a readable message when it lands on your friend's device. This is the key part. Not even the company that runs the service can read your messages.
You know, when you step back and look at the whole picture, you start to realize that encryption isn't just some neat tech feature. It's the bedrock. It's the absolute foundation of our entire digital society.
It's the shield that guards our personal privacy. It's the digital armored truck that secures trillions of dollars in financial transactions every single day. It's literally the wall that stands between your personal data and identity thieves, which makes it the absolute front line of all modern cybersecurity.
So if there's one thing to take away from all this, it's this. Encryption is the foundation of digital trust. Every single time you trust a website with your credit card or an app with your private thoughts, what you're really doing is placing your trust in the power of encryption to keep you safe. Which, of course, leads to a really fascinating question. If this digital lock is so strong, how do hackers even try to break it? And why is it so incredibly hard for them? Well,
that's a story for another time. Thanks for diving in with me on this one.